Hey guys, today we're going to be starting our new unit called Systems of Equations. And today I basically want you to see the difference between a system of linear inequalities and a system of equations. Okay, so first thing, this is a system of inequalities. And on the right side, you have a system of equations. And up to this point, we have looked at both this year, but we haven't spent a whole lot of time on either. So let's kind of do a little bit of review. Okay, so systems of linear inequalities. Okay, this is what we did last unit. Okay, so if we go ahead and look back at this, we can do a quick review. Okay, so our first inequality here is y is greater than or equal to 2x. Well, we always want to graph our y-intercept first. Okay, so since it doesn't give it to us, we're going to assume that it's 0. So let's go ahead and put a y-intercept, or y-intercept here as 0, nice big dot. Okay, and then we can go ahead and assume that our slope is right here, a slope of 2, a rise of 2, a run of 1. Okay, so rise 2, run 1, plot a new point. Okay, now, because you have a greater than or equal to sign in your inequality, that means that we're going to have a solid line. Okay? And lastly, you're going to shade greater than, or shade everything above the line because you have a greater than or equal to inequality. Okay, so your first graph here is your line and your shading. Okay, second one. Let's use blue this time. We have a y-intercept of 1, so go up 1. Plot a point. And then our slope is 1 over 1. So up 1 over 1, plot a new point. Okay. Now, we have a less than sign, so we have a dashed line. And then we need to shade everything that's less than the line. So let's go ahead and shade everything below. Okay, well, what's the only area that's shaded twice? Well, if you go back and look closely, this region right here is the solution set for your system of inequalities. Okay. All right, now let's try a system of equations. Okay, so this is actually simpler in my mind. Okay, so let's start with this guy. Okay, remember, you're not given a y-intercept, so we have to assume it's 0. So let's go ahead and plot a point here at 0. And just like in the last one, we have a slope of 2, and so it gives us a rise of 2, a run of 1. But the great thing about equations is that you only draw a solid line. You don't have to shade, so we're just going to draw a line right through here. Okay, so let's try our other one. Okay, y equals x plus 1, so remember we had a y-intercept of 1 and a rise over run of 1 over 1. And once again, you do not have to decide what type of line. You don't have to shade. You don't have to do any of that. Okay? So how do you decide what the solutions of a system of equations are? You know, inequalities, you see where it's shaded twice. But when you're graphing a system of equations, your solution is going to be the location where the graphs intersect. Okay, so right at this blue dot at 1, 2, that would be our solution. Okay, so that's the spot that we have in common. That would be our solution in this case. All right, we're going to ignore this section here. And we're going to talk about comparing systems of linear equalities to systems of linear equations. Okay, so the first thing you need to know is that there will always be two inequalities when you have a system of inequalities, and there will always be to equations when you're discussing systems of equations. So both of them have 2. Okay, the first difference that you'll see is that systems of linear inequalities, you'll have shading, and systems of equations will have no shading. Okay, so there's your first glaring difference between the two. Systems of inequalities have shading, systems of equations do not have shading. Okay, next difference, systems of linear inequalities, they have either a solid line or a dashed line. Okay, whereas systems of linear equations only have solid lines. So you can have solid or dashed with inequalities, but with an equation you'll only have solid. Okay? And the last one, your systems of linear inequalities have lots of solutions. All right, so let's choose green. Lots of solutions. Inequalities have lots of solutions, and equations have one solution. Okay, so make sure you get these few differences down here, and then we will move on to the next page. All right. Okay, we need to decide which one of these ordered pairs is a solution to the system. Okay, so basically we need to plug in each one and figure out which one works for both. Okay, so let's try 0, 5 over here. Okay, that means we have to plug in 0 for x and 5 for y. So let's try that on this. So instead of x, we'll put a 0, and for y, we'll put 5. Okay, so 2 times 0 is 0, which would lead us to believe that 5 equals 5. And that is true, but to make it work, you have to have it work for both systems. So let's try it on the other side. So we have negative 2 times 0, add 5 to that, and that equals 1. Okay, well, if negative 2 times 0 is 0, does 5 equal 1? Well, no, that does not work. Okay, so since that doesn't work, we know the whole thing doesn't work. Okay, let's try our next one here, and we'll do it in black color. Just a moment here. Okay, so let's try the next one. We have an x of 3, a y of 1. So let's try it. We have 2 times 3 plus 1, and that's set equal to 5. Well, 2 times 3 is 6. Add 1, you get 7 equals 5. Well, right off the bat, we know that this is not true, so this solution B is not true. Okay, let's try one more. Hopefully it'll work this time. And let's use red this time. And our last one, our x is 1, our y is 3. So plug in our x of 1 and our y of 3. 2 times 1 is 2. Add 3, you get 5 equals 5, so that one, it works. Now let's try our other one. We have negative 2 times 1 plus 3 equals 1. Let's see if this one works. Well, negative 2 times 1 is negative 2, and if you add 3 to that, you do in fact get 1. So this one works. So since that's true, we know that this would be a solution. Okay, now, if we wanted to graph this, how would we do that? Well, you would need to solve for y on both of these, get y by itself, and then you would need to graph it. And if you graph those, the lines would in fact intersect at 1, 3. Okay, so at 1, 3, those lines would actually intersect if we graphed them. Okay, let's try one more equation here, or system here, and see what we get. Okay, but before we move on, I got a quick joke for you. Why did the music teacher need a ladder? Think about it. Think about it. To reach the high notes. All right, let's try one more. Okay, we're going to graph both of these and see where the solution is. Okay, so we know that y-intercept is going to be -7. So let's go down over here to -7 and plot a point. And then our slope is going to be 3/1. So from our y-intercept, we'll go up 3/1, and we'll draw a line through there. Okay, so we don't have to dash, we don't have to shade. Okay, next one. We have a y-intercept of 5. So let's draw that point. 1, 2, 3, 4, 5. And we had a slope of -1/1. So we're going to go down 1/1. And you could do this as many times as you want, really. And then you'll draw a solid line. Well, where does this intersect? You can see that right here you have a point 3, 2 as the intersection, so this would be the solution to your systems of equations by graphing. Okay, so you'll notice that it intersects at 3, 2, that is your solution. See ya.